variations of subjective deviations. Abnormal retinal correspondence. On the troposcope, the assessment of retinal correspondence must be done without any fusional stimulus. Therefore, simultaneous perception slides are used. Each haploscopic tube projects an image onto each retina. Under normal circumstances, the brain develops to correlate the visual input at each fovea as coming from straight in front. In the presence of no deviation, the two retinal images from the troposcope are subjectively projected in cortical alignment. This is what they would see in free space. Vision is harmonious, there is no diplopia. The left visual field stimulates nasal retina in the left eye and temporal retina in the right eye. The right visual field stimulates temporal retina in the left eye and nasal retina in the right eye. This is known as normal retinal correspondence. When vision is disrupted during visual pathway development, abnormal cortical alignment of vision may develop. For instance, if one eye is turned outward, the image will land on temporal retina instead of the macula. The location of this is called the contralateral image point. This is what they would see in free space. Vision is inharmonious, there is diplopia. To compensate, the brain may begin to suppress the image. If this occurs over an extended time, the fovea of one eye may start to correspond to a peripheral point in the other eye. The contralateral image point transforms to become a sadofovea. A monocular shift in the whole visual field occurs relative to this point. Now the fovea of the deviated eye is subjectively located on nasal retina, and instead of corresponding to the fovea in the other eye, this point now corresponds to the temporal retina in the other eye. When total transformation of retinal correspondence in one eye occurs, binocular vision is no longer inharmonious, diplopia ceases, and fusion may occur. This results in the subjective deviation varying from the objective deviation and is known as abnormal retinal correspondence. To detect and measure any abnormal retinal correspondence, deviations must also be measured objectively. The size of abnormal retinal correspondence is the difference between full objective and full subjective deviations. On the troposcope, the subjective deviation would now be 0. The fish would be seen in the bowl without any need for a subjective adjustment by the person. However, the objective deviation, in this case, would still be observed as an ESO deviation. The assessor can measure the magnitude of this by repeat alternating the light off and adjusting the tube until both eyes no longer move. This is the objective latent or full angle of deviation. Although the eyes objectively look straight at this angle, subjectively the fish don't line up with the bowl and the person would subjectively appreciate diplopia. That is, unless a suppression scotoma persists to block the appreciation of diplopia. Unfortunately, the peripheral retinal point has less resolution. At a distance of 5 degrees from the macula, best visual acuity decreases to 20/200 or less. Following the development of abnormal retinal correspondence, consecutive deviations can also occur. This may change the abnormal retinal correspondence from harmonious to inharmonious. A further exodeviation may incur crossed diplopia. This is what they would see in free space. Vision is inharmonious, there is diplopia. Images landing on temporal retina are being projected nasally. The image from the left eye is seen on the right side. The image from the right eye is seen on the left side. A further ESO deviation may incur uncrossed diplopia. Images landing on nasal retina have come from the temporal visual field. The image from the left eye is seen on the left side. The image from the right eye is seen on the right side. The size of any crossed or uncrossed diplopia in abnormal retinal correspondence will reflect the amount a deviation is inharmonious. The more inharmonious vision becomes, the greater the angle of diplopia will be seen. On the troposcope, the subjective deviation can be measured if the person moves the haloscopic tube image so that the fish are in the bowl. Variations of subjective deviations.